Mustika, terima peserta Mustika.
Video.
Udah.
Hai Sobat Iptek, tahu kan kalau dunia akan terus berkembang dan berinovasi? Contohnya kendaraan kita yang kini masih menggunakan bensin yang akan habis, sehingga akan berkembang menjadi kendaraan listrik yang bersumber energi terbarukan listrik agar lebih efisien, mengurangi efek rumah kaca, bahkan emisi karbon sebanyak 43% dibanding mobil biasa. Hebat kan? Semua ada berkat komponen utamanya untuk menyimpan energi, yaitu baterai lithium. Baterai lithium adalah baterai dengan energi besar dan bobot yang ringan. Dibanding baterai biasanya, baterai lithium dapat dicas sehingga banyak dipakai di barang elektronik sehari-hari. Ada 3 komponen, anoda, katoda, dan separator. Kandungan tertinggi di katoda yaitu nikel, mangan, dan kobalt. Tapi nikel lah yang bisa menyimpan energi terbanyak sehingga jadi unsur utama pada baterai lithium dengan rasio terbanyak 80%. Negara kita sangat beruntung karena ternyata Indonesia adalah sumber nikel terbesar di dunia. Harusnya bisa membuat industri dan mengolah material nikel menjadi baterai lithium sendiri. Sayangnya Indonesia belum ada wadah bagi para ahli untuk bersatu dan membuat teknologi yang bisa mewujudkan itu. Maka Menristek menugaskan Ibu Evi untuk memimpin riset mengenai baterai lithium dan materialnya yang dilakukan di Puspiptek. Ibu Evi telah menekuni teknologi dan material nuklir selama 30 tahun. Kini Ibu Evi menjadi Presiden MRSI, INSS juga mendirikan NBRI. Ketiga organisasi ini saling melengkapi dalam riset pembuatan teknologi yang dapat mengolah nikel dan bahan baku lainnya menjadi baterai lithium. MRSI fokus meneliti material seperti nikel dalam pembuatan baterai, NBRI meneliti pembuatan baterai yang efektif, dan INSS fokus mengembangkan teknologi nuklir untuk membaca kerja lithium dalam baterai. Ketiganya, selain bertujuan memajukan penelitian, juga menjadi wadah bagi para ahli di Indonesia untuk terus bekerja sama mengembangkan inovasi teknologi energi di Indonesia. Dengan kayanya sumber daya alam dan kemampuan mengembangkan teknologi sendiri, Indonesia akan menjadi negara yang independen dan inovatif. Hai Sobat Iptek, tahu kan kalau dunia akan terus berkembang dan berinovasi? Contohnya kendaraan kita yang kini masih menggunakan bensin yang akan habis, sehingga akan berkembang menjadi kendaraan listrik yang bersumber energi terbarukan listrik agar lebih efisien, mengurangi efek rumah kaca, bahkan emisi karbon sebanyak 43% dibanding mobil biasa. Hebat kan? Semua ada berkat komponen utamanya untuk menyimpan energi, yaitu baterai lithium. Baterai lithium adalah baterai dengan energi besar dan bobot yang ringan. Dibanding baterai biasanya, baterai lithium dapat dicas sehingga banyak dipakai di barang elektronik sehari-hari. Ada 3 komponen, anoda, katoda, dan separator. Kandungan tertinggi di katoda yaitu nikel, mangan, dan kobalt. Tapi nikel lah yang bisa menyimpan energi terbanyak sehingga jadi unsur utama pada baterai lithium dengan rasio terbanyak 80%. Negara kita sangat beruntung karena ternyata Indonesia adalah sumber nikel terbesar di dunia. Harusnya bisa membuat industri dan mengolah material nikel menjadi baterai lithium sendiri. Sayangnya Indonesia belum ada wadah bagi para ahli untuk bersatu dan membuat teknologi yang bisa mewujudkan itu. Maka Menristek menugaskan Ibu Evi untuk memimpin riset mengenai baterai lithium dan materialnya yang dilakukan di Puspiptek. Ibu Evi telah menekuni teknologi dan material nuklir selama 30 tahun. Kini Ibu Evi menjadi Presiden MRSI, INSS juga mendirikan NBRI. Ketiga organisasi ini saling melengkapi dalam riset pembuatan teknologi yang dapat mengolah nikel dan bahan baku lainnya menjadi baterai lithium. MRSI fokus meneliti material seperti nikel dalam pembuatan baterai, NBRI meneliti pembuatan baterai yang efektif, dan INSS fokus mengembangkan teknologi nuklir untuk membaca kerja lithium dalam baterai. Ketiganya, selain bertujuan memajukan penelitian, juga menjadi wadah bagi para ahli di Indonesia untuk terus bekerja sama mengembangkan inovasi teknologi energi di Indonesia. Dengan kayanya sumber daya alam dan kemampuan mengembangkan teknologi sendiri, Indonesia akan menjadi negara yang independen dan inovatif. Hai Sobat Iptek, tahu kan kalau dunia akan terus berkembang dan berinovasi? Contohnya kendaraan kita yang kini masih menggunakan bensin yang akan habis, sehingga akan berkembang menjadi kendaraan listrik yang bersumber energi terbarukan listrik agar lebih efisien, mengurangi efek rumah kaca, bahkan emisi karbon sebanyak 43% dibanding mobil biasa. Hebat kan? Semua ada berkat komponen utamanya untuk menyimpan energi, yaitu baterai lithium. Baterai lithium adalah baterai dengan energi besar dan bobot yang ringan. Dibanding baterai biasanya, baterai lithium dapat dicas sehingga banyak dipakai di barang elektronik sehari-hari. Ada 3 komponen, anoda, katoda, dan separator. Kandungan tertingginya di katoda yaitu nikel, mangan, dan kobalt. Tapi nikel lah yang bisa menyimpan energi terbanyak sehingga jadi unsur utama pada baterai lithium dengan rasio terbanyak 80%. Negara kita sangat beruntung karena ternyata Indonesia adalah sumber nikel terbesar di dunia. Harusnya bisa membuat industri dan mengolah material nikel menjadi baterai lithium sendiri. Sayangnya Indonesia belum ada wadah bagi para ahli untuk bersatu dan membuat teknologi yang bisa mewujudkan itu. Maka Menristek menugaskan Ibu Evi untuk memimpin riset mengenai baterai lithium dan materialnya yang dilakukan di Puspiptek. Ibu Evi telah menekuni teknologi dan material nuklir selama 30 tahun. Kini Ibu Evi menjadi Presiden MRSI, INSS juga mendirikan NBRI. Ketiga organisasi ini saling melengkapi dalam riset pembuatan teknologi yang dapat mengolah nikel dan bahan baku lainnya menjadi baterai lithium. MRSI fokus meneliti material seperti nikel dalam pembuatan baterai, NBRI meneliti pembuatan baterai yang efektif, dan INSS fokus mengembangkan teknologi nuklir untuk membaca kerja lithium dalam baterai. Ketiganya, selain bertujuan memajukan penelitian, juga menjadi wadah bagi para ahli di Indonesia untuk terus bekerja sama mengembangkan inovasi teknologi energi di Indonesia. Dengan kayanya sumber daya alam dan kemampuan mengembangkan teknologi sendiri, Indonesia akan menjadi negara yang independen dan inovatif.
Hello, good afternoon, everyone. Now we're going to start the event. Thank you for your coming to our event on the NBRI Millennial Talks. Before we start, I would like to read the rules for today's event. Okay, so my name is Shinta Widyaningrum, and today I will be the Master of Ceremony of NBRI Millennial Talks, which topic, current state of battery research and study experience in Taiwan and Saudi Arabia. Before that, the rules is this event will be held in 2 hours and 30 minutes. Please mute yourself during the sessions. Please use the feature of raise hand on Zoom if you have any questions in discussion session. Link of the presents will be provided at the end of the event. E-certificate will be sent to the participants who fill the presents form. Okay, so let's start the event with the agenda. So today we're gonna open the Zoom participants and we continue by opening speech and introduction from the NBRI, introduction of PT Infinity Energy Indonesia, LCA for graphene production, solid-state battery, LMFP battery cathode, lithium metal battery, NMC battery cathode, study in Taiwan, study in Saudi Arabia, and then we continue with the Q&A session, summary, appreciation, and announcement, and then closing participation. But before that, let's sing the Indonesian National Anthem. Okay, now we're gonna move to the first agenda, which is a opening speech from Professor Dr. Renat Evi Kartini. Professor Dr. Renat Evi Kartini is the founder of National Battery Research Institute, or NBRI, President of the Material Research Society Indonesia, or MRS-INA, Senior Researcher Center for Science and Technology for Advanced Materials, National Nuclear Agency of Indonesia, or PSTB in Batan, Bachelor Degree Physik Bandung Institute of Technology ITB, Doctorine der Natuurwissenschaften, or Dr. Renat from Fachbereich Physik Technische Universität Berlin, or TUB, Berlin, Germany, graduate postdoctoral from Department of Physics and Astronomy McMaster University, Hamilton, Canada, and Professor Research Condensed Matter Physics, Indonesia Institute of Science, Jakarta. To Prof. Evi, the time is yours.
Okay, thank you, Sinta. Thank you, everybody. Good afternoon. From Indonesia is good afternoon. From other country, depending on the zone. Yeah, good evening, maybe good morning. I'm here on behalf of the founder of the National Battery Research Institute. Welcome all of you. The first, the speakers, yes, the millennial speakers for this NBRI Millennial talks, the series talk, and we will introduce you with all the well, the great speakers, yeah, the future millennials. Okay, and then I would like to greet also to the co-founder of the National Research Institute, Prof. Alan Drew. He is already with us. Okay, he will join us with this event. So I would like to share about what is the NBRI. Okay, yeah, as mentioned by the MC, so the title of this Millennial Talks, Current State of Battery Research and Study Experience in Taiwan and Saudi Arabia. So this is, we are pleased to introduce the moderator, Cipta. Yeah, Cipta also he graduated from University of Indonesia. And then Anissa Wijayanti from University of Indonesia, Rizka Ayu Puspita from the National Battery Research Institute, Muhammad Fahrudin is the Lca researcher from Batan, National Nuclear Energy Agency, and then also Lisdia Ainia from Institute Teknologi Kalimantan, but she is now currently in Saudi Arabia. And then our also guest speaker, Egi Aditama, who just finished the study, master study in Taiwan and will pursue a PhD study in Germany. Okay. Okay, this is about me. Sinta already mentioned that. So if you see my right hand is there is a battery, and then my blazer with the nuclear. So that is both of the specific I'm doing in the research, yeah, the nuclear and the battery research. Okay, this is several of the words. Okay, yeah, the story of the National Battery Research Institute, actually the concept already started since a few years ago, since 2014. Yes, that is important that to gather the whole stakeholder, not only researcher, industry, but also the from the university. Yeah, so I led also the consortium, national consortium of the battery, national battery. In 2016, 2018, yes, we received the grant from the Ministry of Research and Technology. Yeah, we meet also the minister. Okay, as the president of Material Research Society Indonesia, we held a conference, international conference that attended more than 15 countries. So the last one is the 2019 in Bogor, International Conference at Material Technology and International Conference Multidisciplinary Research. So during that time, we launched the National Battery Research Institute because it is important. Yes, that is the, so we already launched in 2019. And then at the time, so our co-founder, Professor Alan, attended the conference, and then he showed that how important this is, the not only the concept, yeah, the Battery Research Institute. So we agree to make the MOU, and then we continued by applying the GCRF from Global Challenge Research Program from UK. And then finally we received this starting last year and until now to establish the National Battery Research Institute. We benchmark to the Faraday Institution in UK. Yeah, so they have that. Now, so what is that NBRI? So NBRI has already legally established in 17 December 2020. Yeah, so as Yayasan Pusat Unggulan Inovasi Baterai and Energi Terbarukan, or as the Foundation of Center Excellent Innovation in Battery and Renewable Energy. So this is important part, yes. So we want to gather the scientists, industry partner, research, and environment, not only Indonesia but all over the world, yeah, in order to reduce the battery cost, the weight, volume, to improve performance, to develop the whole strategy, including recycle and reuse. Yes. So this is the concept at the beginning, yeah. So we have to get together all the researcher, the student, the platform, the research institution, the government, the investor, and also the industry. Yes, the industry also, because the concern of industry, what is the problem? So we, from the researcher, we have to find the solution. Yeah, so we have also to produce some product. Okay, so this is our vision. Yeah. At the end, we want that Indonesia to be independent in energy, have the manufacture in battery, we're using locally resources. That is the main, yeah. So we have milestone. Milestone, this is from the testing, standardization, and then we plan to have also the training certification. Yes, that is should be a training, yeah, personal certification, and also research innovation, recognition, and also testing laboratory, startup incubator in this field. And we wish someday we can also open the technical university, the battery or related to energy, climate change, and also in the future the Indonesian manufacture. So we have this program in 5 years, and then we already discussed, and then audience with the 3 times with the Minister Research and Technologies. No, this is under consideration. Yeah. Okay. Again, we want to bridge the research, innovation, and to scale up. So the benchmark, not only Faraday Institution, so we have also the benchmark to UK Industrialization Center and also to Silicon Valley. Yeah, so our dream someday, yes, we'll have this building that, for we get together. Yeah. Okay, what is the activity of NBRI? So this is the last year activity when our co-founder, Prof. Alan, came to Indonesia, and then we met the Minister Research and Technology on almost 1 year. Yeah, next week will be 1 year, and then he approved that also the NBRI, and our website also launched by the minister, yeah, on the 16th of September. So if you open the website, next Mr. Adit will explain that in detail. Yes, that is their platform. Yeah, so we have one NBRI map. So we want to show that research facility at the beginning from Indonesia, maybe later on from all over the world. Yeah, so who does the research on battery and renewable energy, and then also the industry, that end user, manufacturer, resources, that is very important. Yeah, and also the for during this 1 year, last year, so we have exposure to more than 3,000. I think this is last year, but this more than 3,000, more than 18 countries. Yeah. Okay, so this is our activity. We invite the minister, we invite also the CEO of the National Enterprise State, and then also the Minister of Transportation, discuss about the regulation. We have the lectures from Canada, from Singapore, from Australia, and the coming will be from USA. So this time is this event is the Millennial Talks, the second one. So I hope that all of you, if become the member and you can show your ability, so welcome for the Millennial Talk. Yeah. So we have also collaboration with industry. Yeah. So this is our audience. Okay. So you may all guys may be here. The participant curious who are attending this seminar. Okay, so let me open this. By occupation, it is mostly the millennial talks. This is attended by students, so they register 64% student. Yeah, among this 120. This is the last night. Yeah, the last night registered. Yeah, so maybe today's more, and because we have also YouTube, the other. So we have the researcher, also non-researcher, and from government and non-government. Yeah, so this is amazing. Yeah, so the students is. All the participants coming from more than 60 institutions. So I cannot say one by one. Yeah, so it's amazing. Yeah, they are also from university from not only from over Indonesia, but also from international. Yeah, from Malaysia, from Korea, from Saudi Arabia, from Germany. Yeah. Okay, so it's amazing. And then this is it's good. All this millennial, yeah, 62%. So the student is a millennial who was born after 2000, yeah. So the age is 18 to 25 years old. So welcome all of you, millennial. Yeah, you will make the world the better world for the future. And besides Indonesia, they are attended by various countries. This is here from Belgium, from Germany, Saudi Arabia, Malaysia, UK, and maybe also USA. Yeah, not written here, and also from Indonesia. So, so this is really international millennial talk. Welcome to all of you. Okay, don't worry, everybody, they have a chance. Welcome to become the member of the NBRI. So we'll have this card, and then later on it will be introduced how to become. Yeah, and don't forget, next week we will have the lecture from USA. Okay, okay. Once again, have a good have enjoy this talk with millennial, and then discuss a good discussion. And then well, before I finish this, maybe I want to invite maybe a few words from the co-founder of NBRI, Prof. Alan. Are you there? Can you say something? Thank you.
Hello, everybody. Thank you very much for the organising this event. It's a great pleasure to be here with Professor Evie, as ever. I think it's true that my engagement with the NBRI has been relatively brief compared to Professor Evie. I've been here on the scene for around 2 years, whereas Professor Evie has been in the long run. But I mean, it's been a fantastic 2 years that I've been here, and we've achieved so much. And I must say that's a lot of that is down to actually having the money to employ staff to run events like this, because without the great staff that we have who need to be paid, it would be very difficult to do anything. I think if it's okay, I'd like to take this opportunity to tell everyone here that Professor Evie and I have just recently been awarded another research grant. Not only will this enable the NBRI to continue its activities for the rest of 2020 and beyond, 2021 and beyond, there's also quite a special feature to this research grant. So it's a British Council research grant, and it will have one of the funding conditions is that we operate a research grant scheme ourselves. So this means that the NBRI receives money from the British Council, so from my government, and then we distribute it to Indonesian colleagues to run research projects, short-term research projects on the energy agenda. So it could be batteries, or it could be slightly wider than just batteries. This will be accompanied with a workshop in the summer, a 3-day workshop, which is aligned with COP26, which is the big climate change summit that happens where governments make commitments to climate change. So we have this amazing opportunity to both contribute towards the COP26 agenda, fund Indonesian research, and we're not talking about small money here. The 6-month research projects, there'll be a few of them, 5 or 6 of them, with funding up to £10,000 per project, which is a considerable sum. And there'll be money to attend the COP26 Glasgow for some Indonesian researchers in November this year. And so we will make an announcement in probably towards the end of this month. We need to have a meeting to discuss how it all works. But I thought I'd give everyone here a pre-announcement that we're going to be running this workshop and grant award scheme over the next few months. And I do hope that you put your thinking caps on and start coming up with ideas for research projects that you might want to do during 2021 and into 2022. Okay, thank you everybody.
Okay. Okay, thank you, Alan. Thank you, Alan. So all of you must be curious about that. What Prof. Alan already mentioned. But coming soon. Okay, we will distribute this information soon. Yeah. Just wait, and be member of the NBRI. Okay, so I'll give you back to Sinta. Yeah. Thank you. Thank you, Alan.
Okay. Thank you, everyone. And thank you, Prof. Evie and Prof. Alan Drew, for such an amazing and great informations. So now we are going to the next speaker. Let me share my screen. Wait a minute. Okay. Sure. Okay, so now we are going to introduce Mr. Adit Trivigono. He was graduate from Bachelor degree on Prasetya Mulia School of Business and Economics, Chartered Financial Analyst or TFA Level 1 course in Bina Nusantara University, Sharia Stock Investment School Level 1 and 2 IDX Indonesia, How to Find a Supergain Postdoc by Billy Budiman course, Finance Director of National Battery Research Institute, PT Trimitra Jaya Mineral subsidiary of PT Noble Capital as Corporate Finance, PT Bahtera Karimun Sejahtera as Finance Manager, PT Noble Capital as Industry and Financial Analyst, and PT Prudential Life Assurance as an agent. To Mr. Adit, the time is yours.
Okay, thank you very much for the introduction, Ms. Sinta. I will share my screen. Okay, I hope you can see my presentations. So good day, ladies and gentlemen, honorable speakers, honorable panelists, and all the participants on Zoom meeting, conference, and YouTube streaming. My name is Adit Trivigono. I'm the Finance Director of NBRI. First of all, I would like to say thank you for the time that is given to me to present briefly about NBRI website. So as mentioned by Prof. Evie recently, NBRI is an Indonesian independent institute for electrochemical energy storage and skills development, and we aim to contribute to overall research capacity and training environment in Indonesia in battery research. And this vision is, our vision is to gather all Indonesian stakeholders in battery research and production, and also to help strong national batteries research and increase the visibility of batteries research at government level. So we have special tools, as mentioned before. We have the NBRI One Map, where you can find about resources and users, battery manufacturers, and research facility. So you can see our map in our website. So we separate the cluster from resources and users, battery manufacturers, and facilities. So end users is for the map that shows the user of the battery. Battery manufacturer is to show the battery manufacturer companies, and the facility is to show the facility, research facility related to battery. And we have plotted the location of each stakeholder in our map. So if you want to have your companies or institution to be plotted in our map, please contact us directly, or you can register as member. So you can visit our website and register as a member. So you can choose an individual, institution, or corporate. And so you can always have update for our next event. So for our panelists and speakers, also audience that represents one of the stakeholders of battery, and also the millennials, the university students, please have a minute to register as a member on our website, since we are coordinating with the Ministry of Research and Technology to gather the stakeholders of battery. So this is our website. It delivers our vision to have a broad picture on the battery industry's ecosystem in Indonesia, ranging from resources, end users, manufacturers, and research facility. So our website is www.n-nbri.org. So this is our first homepage. You can see all information about NBRI and our vision, our milestone, and our team members, and also our expert panel. We also have these features at NBRI platform. This is our publication, so we can post our own publications such as papers and journals related to energy storage in our website. And also we provide links and platforms for members to promote and share their research publication on our website. On research panel, there are several main topics related to lithium-ion battery insights, such as lithium-ion, beyond lithium-ion, industry concern, battery characterization, Indonesia research community, Indonesia research highlights, and also Indonesia national research priority. All of these topics related to novelty, research, project, and also recent issues that we concern in Indonesia. We also have these opportunities platform in our website. This is a panel that will show the opportunities that will be given by the industry, such as vocational high school internship, undergraduate internship, job opportunities, and industry fellowship. This is all with our corporate members. Also, we have a feature for education. So we have a training program and seminars for vocation and corporate members that want to learn more about energy storage. So we provide the syllabus and the lecturers, also the facilities for practice. So therefore, the program is not only theory, but application too. The training and seminars are various and available for all stages, from undergraduate until PhD and early career researchers. So this is the original concept of NBRI, founded by Prof. Evi Kartini. And it was launched in October 2019 and established legally in 2020. So we are a platform that combines from academic, government, and also the corporate to have a new research that are ready to be industrialized. So the research is not only stopped as paper, but it can be developed into end product. And this is our milestone, our 5 years milestone to support Indonesian battery manufacture with local resource, starting from its raw materials and human resources. We also correspond to Indonesian government to establish the biggest integrated center of battery manufacturing industry in the world, focusing on electric vehicles. And also we aim to establish a battery university in 2024 and startup incubator in 2023. This is to support the environment, include the human resource skills and small enterprises of battery industry in Indonesia. So one of the products that is developed is Powerwall. It's a rechargeable lithium-ion battery stationary energy storage intended to be used for residential purposes, which can store electricity from solar panels or grid power. So it can be used for backup power when blackout, and also to be used at night where solar panel is off. So this product is developed by PT Infinity Energy Indonesia. So it's a company that also manage the NBRI in terms of management and administration. So Infinity Energy Indonesia was founded in 2018 as a one-stop green and safe energy solution company in building Industry 4.0. So we are committed to provide safe and green power solutions for all of our partners. And our values lies in the flexibility to customize your own product according to your needs. We provide the battery module that suits every segment needs. So for example, to charge your electric vehicles. And the products that are developed by Infinity covers all segments such as residential, industrial, and transportation. And one of our greatest invention is the power wall. So we also develop smart solar lighting that back up by solar panel and lithium-ion battery, which is more efficient and durable than the lead-acid battery. We also have developed a portable energy storage to be used in remote areas. We have developed a battery for electric motorcycles that can be used customized based on the specifications. Okay, I think that's all I can share about our website and about Infinity Energy Indonesia. For further information, you can contact us through email or visit our website. And also, please have time to register as our members in NBRI. So, thank you so much. We'll give it back to the floor.
Okay, thank you so much, Mr. Aditya Wiguno, for sharing the presentations. So now on, without further ado, I would like to give the time to Mr. Cipta Pahengar to lead today's Millennial Talks discussion. But before that, I would like to introduce Mr. Cipta Pahengar Supriyadi. Mr. Cipta Pahengar Supriyadi is a senior researcher on the NBRI. He was graduate from Sekolah Tinggi Nuklir or Polytechnic Institute of Nuclear Technology, Nuclear Chemical Engineering, graduate from Master Degree on Metallurgical and Material Engineering, University of Indonesia, was selected as the 4th ASEAN Synchrotron Science Camp 2015, held by Synchrotron Light Research Institute, or SLRI Thailand, and National Seminar of Neutron, X-ray, and Nuclear Analysis, Technique 2015, held by Nuclear Energy Regulatory Agency of Indonesia, or BPTEN. To Mr. Cipta, the time is yours.
Okay, thank you, Ms. Sinta, for the introduction. And I would like to say thanks to Prof. Evi as the founder of NBRI and Prof. Alan as the co-founder of NBRI. And it is my pleasure to guide all of you as a moderator in this event. And without further ado, I will introduce our first speakers, Ms. Rizka Ayu Puspita. She is a junior researcher on NBRI and graduated from Polytechnic Institute of Nuclear Technology, National Nuclear Energy Agency (STTN) Batan, and selected participants of Science Camp in SLRI Thailand. She has been a head of academic subbureau PSDM department in HIMA TKN, and also head of academic subbureau PSDM department in BEM STTN. To Ms. Rizka, the time is yours.
Okay, thank you, Mr. Cipta. Please allow me to share screen. Okay. Okay, hello everyone. I'm Rizka, and I'm here. I will present my experience about my previous research about the life cycle assessment on graphene production for NMC cathode. Okay. And here is the outline of my presentation. First, I will talk about the introduction or what is LCA, and the next is the life cycle assessment, and then we talk a brief about graphene and NMC, and I will talk about our previous research, and I will sharing info about Lca, and then the next and the last is the conclusion. Okay, for the first is about the introduction. Why LCA is important? So it began in the 18th century when the Industrial Revolution began. The industrial society has grown up and increased in production of goods and also services. Because of the availability of raw material is unending, and the ecosystems are not able to absorb pollutant anymore, environmental danger have risen. So this simulated the birth of environmental policy, and thus researchers develop environmental assessment methodology to develop cleaner manufacturing process or achieving sustainability industry, which has motto meeting the needs of current generation without sacrificing the needs of the future one. So here, researchers are developing the life cycle assessment method, or we already known as LCA. So what is LCA? LCA, or life cycle assessment, is actually a technique for assessing the environmental aspects associated with a product over its life cycle. And this is the LCA framework. There are 4 steps for doing the LCA, and there are 2 main regulations for LCA. There are ISO 14040 2006 and ISO 14044 2006. And in Indonesia, Indonesia has adopted this ISO by SNI ISO 14044 2017. Okay. So this is the life cycle assessment stages. The first start with the goal and scope definition. So we have to set the goal of study and the scope definition. For the first, we have to set the functional unit. What is the functional unit? This is a value that measures of the function of the studied system, and it provides a reference to which the inputs and outputs can be related. The functional unit is the key parameter of LCA study. So the value must be precise and comparable if we want to make a comparative study. And after we set the functional unit, and then we set the LCA boundary system. Actually, in the ideal boundary system for LCAs start from cradle to grave, but sometimes it's difficult to analyze all of the parameter if we directly set the boundary system from cradle to grave. So it can be divided to 4 boundary system. You can choose boundary system start from cradle to get, or maybe get to get, or maybe get to grave. And if we set the boundary system start from cradle to grave, it means that we review the process from the material extraction up to the disposal of the material. If we set the cradle to get, it means that we review the process from material extraction up to the production of the material. But if we only review on the get to get, we only need to review about one production system. But if we want to review about the get to grave, it means that we have to analyze the product system up to the recycle of the end of use of the product. And the second stage is the inventory analysis. This is a very time-consuming process, because in this process we need to collecting all of the data that is needed in the LCA methodology, such as we need to we need to consider what is how far the material travel, and how many water that is being used, and then how about the electricity, and also the waste that is resulted by the process. After that, the data is collected. We have also draw the block process system, which is switched to the boundary system that is chosen before, and after that we can calculate the mass balance and also the energy balance by this block process. And the next is the life cycle impact assessment, or LCIA, where in this stage all of the data that is complete from inventory analysis is being calculating by software. In here there are some software that can be used for the LCA, such as OpenLCA, SimaPro, Gabi, etc. And also in here, OpenLCA is a free software that can be accessed. And in the software, there are two tools. There is baseline and database. In the baseline, this is the baseline. CML, recipe, TRACI, ILCD, and etc. You can choose the baseline based on your data, based on your needs. And also, you can input the data from the inventory to the database that is an EcoInvent, ExioBase, RV, AgriBalis, needs, etc. You can combine or choose the best data for your calculation. Okay, this is the database. This is the database that the display of database in OpenLCA software. This is for this is the database, and this is the baseline. The baseline consists of the description of impact assessment, like the acidification, eutrophication, freshwater aquatic ecotoxicity, and etc., with their reference unit as follows. This is the display in OpenLCA. Okay, and the last stages is the interpretation. There are three stages of interpretation. For the first is the identification of the significant problems, such as maybe the problem comes from the energy supply, the waste, the transportation, or the raw material extraction. After that, if we have found the significant problem, then we need to evaluate the problem, such as we need to consider the sensitivity, and then completeness of data, and also the consistency of data. After that, we can make conclusion that consists of comparison and recommendation. Okay, and the next is I will tell you about a brief story about graphene. Graphene is composed of a closely packed single layer of carbon atoms that forming two-dimensional honeycomb lattice plane. It has outstanding properties such as very high specific surface area, thermal conductivity, and also the electron mobility. So graphene is widely used for electronic field, and graphene can be synthesized in two methods. There are top-down and bottom-up. And here is the example for the top-down synthesis, like mechanical exfoliation, chemical exfoliation, chemical synthesis, while for the bottom-up, such as pyrolysis, epithelial growth, CVD, and the others. And the next is about the NMC cathode. The NMC cathode has raised its popularity due to the electric vehicle. What is NMC cathode? This is actually the lithium, nickel, manganese, cobalt oxide. And here is the chemical formula. And it has very good properties such as follow because of the combination of nickel and mangan content here. The nickel has high specific energy but poor stability, while the mangan has a spinal structure, Tulsi flow internal resistance, but offer low specific energy. If we combine both metal, so we will get these outstanding properties. So this battery is preferred candidate for the electric vehicle and has the lowest self-heating rate. And there are some types of NMC. There are NMC 111, NMC 811, NMC 532, and NMC 622. This value is for the composition of nickel, mangan, and also cobalt. And NMC has a crystal structure as follow. This is layered crystal structure. Okay, this is our previous research. So I conducted this research for my undergraduate thesis. I have done a life cycle assessment with cradle to gate comparative study between graphene production by electrochemical exfoliation with flake graphite as raw material, and also the graphene production from green synthesis approach with rice husk as the raw material to increase the specific capacity of NMC Cathode 111 by adding graphene up to 10%. Okay, I did the research on the LCA research using open source OpenLCA with the baseline that I choose is the CML baseline, and I combine some database such as Ecoinvent, Agribalis, and etc. And actually, you can easily get this software by visit the website here openlca.org, and you can also download the some free database in this website nexus.openlca.org. So this is the result from our previous research. There are 5 impact category that arise from both process of graphene synthesis. The first is the eutrophication here. The blue color is for the graphite material, raw material, while the yellow for the rice husk raw material. And the eutrophication comes from the pollution that caused by nitrogen oxides, sulfur dioxide, and also nitric acid waste. This comes from the transportation and also the graphite recycle plant. And the acidification, and the next is the acidification. Acidification comes from nitric oxide and sulfur dioxide, and while for the photochemical oxidation here comes from the carbon monoxide and sulfur dioxide, while the human toxicity comes from nitric oxide, sulfur dioxide, and particulate matter, while the global warming potential comes from the carbon dioxide emission. So from the impact categories that arise for both processes, I suggest two recommendation improvement. The first recommendation improvement comes from substituting the transportation model from a truck to electric vehicle, and surprisingly, the impact value decreasing significantly. And the second, I suggest to substitute the solar fuel to biodiesel fuel. Here is B30. It means that the biodiesel here contains 30%, while the 70% is still in the diesel fuel. And by substituting the truck to electric vehicle is more significantly decreased the impact category value. Okay, and how about life cycle assessment in Indonesia? Actually, in Indonesia, there is an institution that concerned about the life cycle assessment development, and the name is Indonesia Life Cycle Assessment Network. We can find the website here, and this is Lca actually a voluntary initiative with the objective to promote LCA application in Indonesia. This is a network that used to share information and to build capacity on LCA to interested parties in academia, government, and also industry. They have.
Sorry to interrupt, but you have 1 minute
Okay.
more.
Almost there. They have two main program. For the first is to enhance the LCA research in Indonesia, identifying and outreaching available LCA related resources, expertise such as for expertise, publication, inventory data, software, and etc. You can visit this web for further information. Okay, the last is the conclusion. So for the first is the LCA is one of the environmental assessment technique to study the impact of a life cycle process to environment, and it is widely used in any fields of study, include nanomaterial synthesis, lithium-ion battery, and etc. The second, the data that and assumption that used in LCA will determine the validity of LCA results. So we have to be careful about the inventory data. And the last is the database improvement for each country is important because it will affect to the LCA impact result. Okay, thank you for your attention.
Okay, thank you, Ms. Rizka, for delivering such an amazing talks. It is nice to hear, or it is nice to know that there is an analysis technique that can analyze the impact of the production of the graphene and production of the NMC, graphene into the NMC, since the NMC will be a trending battery technology in the futures. Okay, for the next speakers, I would like to introduce Miss Lisda Ainia. She has a bachelor degree from Department of Physics, Faculty of Science, Food Technology and Maritime, Institute Teknologi Kalimantan, or ITKI Engineering, runner-up in Tokyo Tech Indonesia Commitment Award 2019 in Tokyo, Japan, a teacher at the Indonesian School of Makkah, girls section in Saudi Arabia, and was a laboratory assistant of Fundamental Physics Department and teaching assistant of Fundamental of Physics course. To Ms. Lisda Ainia, the floor is yours.
Thank you so much, moderator, for inviting me. Can you please accept me to share my screen?
Yes, please, Ms. Lisda.
Thank you so much. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First, thank you so much for giving me the opportunity to share my story and my perspective about the current research in batteries. Thank you so much, Professor Effie. Thank you so much, Professor Ellen and NBRI. So my name is Lisda Ainia. You can call me Lisda. And today I'm going to discuss, actually, rather than say present, I would like to say it's a discussion and to share my perspective and also my thoughts. So actually, I graduated, as mentioned by the moderator, from Institute of Technology Kalimantan or Kalimantan Institute of Technology back in 2019. And for my dissertation and also my internship projects, I collaborated and worked directly under two amazing researchers, Professor Evi Kartini and also Mr. Rodil at the Integrated Coin Cell Laboratory at the Nuclear Energy Agency of Indonesia. So the output from this research gave me the opportunity to present it in front of the Indonesian professors and postgraduate students at Tokyo Institute of Technology or Topodai back in 2019 during a competition called Tokyo Tech Commitment or TICA 2019. So just a brief information, TICA is actually an annual event hosted by the Indonesian Association students in Topodai, Tokyo Institute of Technology. So if you're interested, you may look that up and then register yourselves. It actually begins on late April. And so today I'm going to share with you about my research about finding the perfect material for solid electrolytes in order to produce all solid state lithium ion batteries. So first, batteries. We might not realize how important batteries are until we're rushing out to our charger, plug it, and make sure that we don't get cut out in the middle of conversation. That's just how important batteries are. And no wonder batteries are called a triumph sign. And even in tech talks, they claim that batteries are actually the missing link when it comes to the application of renewable energy. As far as we know that renewable energy is considered to be one of the most effective ways in order to reduce the effect of climate change. So there are actually so many types of batteries, but one of the most prominent batteries is actually lithium-ion batteries. If you're asking why lithium-ion batteries, it's due to their advantages, but mostly because of its high energy density. So what is energy density? Energy density is actually the capability in order to store as much as energy as they can. So the higher the value, the better it is. And of course, even though the perfect, quote unquote, perfect batteries, they have their own shortages or disadvantages. In batteries, so this is actually a very compacted container. There is a cathode, there is an anode, there's also a separator in order to separate between cathode and anode, and there's also an electrolyte. So the problem is with batteries, there is something called liquid electrolyte. So liquid electrolyte is actually a medium to migrate. So ions migrate from cathode to anode, and yeah, vice versa. But the problem with liquid electrolyte is that the leakage, the special sealing, because it is the liquid inside a compacted container, we need a special sealing, and then also it tends to combustion. And then the other thing is that with separator, it has low melting point and short circuit, and also it tends to combustion. What we proposed in our research is actually something called all solid state lithium ion battery. The keyword is actually all solid state. So the component is actually all of it solid. Rather than using liquid electrolyte, which is the source of the problem, we convert it into solid electrolyte. What we offer from this solution, there are three things. First, non-flammable, because we do not use liquid anymore inside of a container. And then there is no leakage because, yeah, there is no liquid, right? And then it has longer lifespan. So for the solid electrolyte, we decided to choose not lithium phosphate, not just lithium phosphate, but a compound, a mixture between lithium phosphate, lithium iodide, and also AgI with composition 0.5, 0.25, and 0.25. If you ask us why we decided to choose this composition other than others, because it's actually based on previous research and by Mr. Otoma, and he succeeded his research that with this composition, it will get the highest conductivity to the power of -4. So about conductivity, from the word itself, conductivity means actually the way to conduct electricity. So the higher the value is, the better it is. It's in the market, it's actually around to the power of 0, 1 to +1. It's actually better, the higher it is, the better it is. So second, in our research, we're not just talking about solid electrolytes, but we're also tackling the issue of cathodes. Why cathodes are also important tool to improve a battery. Two things. First, because it increases the safety and also energy density. Second, if we're looking to apply this battery in a bigger scale, we're speaking about industrial scale, we must consider cathodes because cathodes fall until 25% of the cost reduction. So if you want to reduce the production budget, might as well to control the cathodes production. So from all types of cathodes, we decided to choose the lithium iron phosphate simply because because of this low production cost, because we are considering the cost reduction, and also with relatively high specific activity. And this is the purposes of our research. There are two things. We're synthesizing the cathode with an addition of acetylene black. Why acetylene black? Because acetylene black is actually an active carbon. It has the ability to increase the energy density of a lithium iron phosphate. And this is the thing is that we're synthesizing the cathode lithium iron phosphate also to compare it with another addition of solid electrolyte. So keep in mind, this is lithium iron phosphate with addition of acetylene black, and there is also another cathode, lithium iron phosphate with addition of acetylene black, and also we add 5% of solid electrolyte. Why we have to add the solid electrolyte? So the problem with the addition or with the conversion from liquid electrolyte to solid electrolyte is that there is something called solid interface. That this is solid, this is solid, this is solid. So there's something called solid interface. In order to reduce the solid interface, researchers all over the world have attempted several ways in order to do that. However, it's still in progress. But what we propose is that we decided to add a small portion of solid electrolyte inside the cathode. So the electrolyte and also the solid electrolyte and also the cathode does not have so many differences because there is something from the solid electrolyte inside the cathode. And then for the method, actually, we simply wet chemical reaction in order to put the acetylene black inside the cathode. And then for the lithium iron phosphate, the solid electrolyte, we decided to ground it inside of a glove box in order to minimize the oxygen. And that's it actually. And then we decided to do some characterizations on SEM, XRD, and LCR. But in this discussion, I'm not going to discuss about SEM, but just focusing on XRD and also LCR. First, XRD. As you can see, that there is two patterns. This is what we call patterns in XRD. This is the orange one and also the blue one. So the orange one is for the lithium iron phosphate plus zero addition, which means just this lithium iron phosphate with the addition of acetylene black, and then we compare it with the pure lithium iron phosphate. So what is XRD tells you? XRD tells you about the structural properties of a material. So our purpose actually to examine it with an XRD is actually to make sure that even though after the addition of active carbon, it has the same structural properties as a lithium iron phosphate. As you can see that here in the table, that the crystal system of lithium iron phosphate C after the addition of acetylene black, it has orthorhombic crystal system and also with P and Ma as space group. And these two categories, these two tools are actually the same lithium iron phosphate. So we can safely say that even though after the addition of acetylene black, it has the same properties of lithium iron phosphate. And then the second thing is that after that, we compare it with zero addition, also addition. As you can see, it also has the same properties of before lithium iron, pure lithium iron phosphate with orthorhombic crystal system and also P and Ma phase group. And now the other thing I'm going to discuss with you about is the LCR result. What is an LCR? So LCR tells you about the conductivity value. It tells you about how conductive the material is. The higher the volume, the better it is. That's what we're looking for. So as you can see, there is a graph. The axis X is the lock frequency, and then the axis Y is lock conductivity. As you can see, there are two colors, black and also white. The black color is actually for 0% addition of solid electrolyte, and then for the red one is actually for after the addition of 5%. I'm going to show. And then we did some computation in order to see the exact value of each material. So here, there is, I show you the first conductivity value of just pure lithium iron phosphate. It actually has a relatively low conductivity value from 10 to the power of -9 to the power of minus 11, as you can see. So after that, we decided to examine after the addition of acetylene black here, this one. As you can see, there is an increment in terms of conductivity until the power of -4. -4. So it means that acetylene black succeeded to increase the conductivity value of the lithium iron phosphate. And then we can see, and then we compare it with the addition of 5%. It has even better, it actually slightly lower conductivity value of, it actually has the same, so -4, however, the 0%, it has slightly higher conductivity value. So what does this tell you? It tells you that actually the addition of solid electrolyte, on the other hand, even though actually reducing the solid interface between two materials, but at the same time, they're also reducing the conductivity value. It's actually our homework in order to research further, to dig further what is happening. That's it. And this is the conclusion. There are 3 conclusions. First of all, that we succeeded to synthesize and also to characterize the lithium iron phosphate seed, and we succeeded to show you that the structural and electrical properties are even better after the addition of acetylene black. And then the structural, from the structural perspectives, orthorhombic with space group of the NMA, and also the conductivity, we succeeded to increase the conductivity to even -4. That is actually a very good sign. Okay, that's it. Thank you so much for me. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Ms. Lisda, for the concise but a comprehensive talks about the solid electrolyte and also the improvement of the LFP, right? Okay, so it is important to improve to the solid electrolyte to improve the safety and improve also the cathode for the more affordable and more or higher energy density battery in the future. Okay, maybe we will advance to the next speakers. For the third speakers, I will introduce Ms. Anissa Wijayati. She has a bachelor degree on Pajajaran University, majoring in chemistry, and acquired her master degree in University of Indonesia, majoring in metallurgical and materials engineering, joint supervision program with Osaka University, PITA A University of Indonesia Research Grant, member of Students Creativity Program of Research, graduate thesis project of University of Indonesia, and joined a battery study in National University of Singapore, and conduct an undergraduate thesis project in Pajajaran University. Okay, Ms. Anissa, the time is yours.
Okay, thank you, Ms. Akita, for the introduction. First of all, allow me to share the screen. Sorry, okay, this one. Okay. 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 Assalamualaikum warahmatullahi wabarakatuh. My name is Anissa Wijayati, and I'm here to share my experiments during my undergraduate and my thesis project, especially in lithium iron phosphate battery cathodes. And I'm sorry, the presentation is, there is a glitch in my presentation, so I have to use the PDF versions. So first of all, let me start with the introduction. In Indonesia, digital opportunities, as you can see there are so many opportunities in digitalization in Indonesia, especially in mobile internet usage, cloud technology, IoT, and big data. All of those activities need a well energy storage device. But on the other hand, we have to consider the trilemma energy in batteries, such as we have to consider the security of supply, their affordability, and their sustainability. And then this is the region plot that show the specific energy, which is how many energy that can be stored in the battery, in the X value, and the specific power. That means then how many voltage that can the battery deliver in the system. So first of all, in the long-term technology, all of those components in the battery will be shifted to the solid states, like solid anode, solid cathode, and solid electrolytes. But in this short term, we want to optimize the battery with liquid electrolyte, which meets the specific energy and the specific powers. And based on this region plot, we have several candidates for the potential materials, which is the lithium iron phosphate and lithium metal oxides. And after we determine the potential materials, the next step is we have to choose which one of the selective materials that can be used as the cathodes. First of all, we have to know the functions of the cathodes, and as you can see that the cathode's function is as a source of the electron or the donor protons, and then we have to determine the constraints. The constraint is what is non-negotiable variable that have to be present in the batteries, such as we have the battery must have high conductivity and high working voltage and must be rechargeable and good SOX. And then we have to determine the objective or what function that can be minimized or maximized. For example, we want to maximize its potential, we have to maximize its capacity, but we want to minimize the cost. And then you can add a fear variable, if any. So first of all, after we determine the category in material selections, then the next step is we have to determine which cathode material based on pairwise comparisons. In battery, there are so many terminology that influence the performance of the battery, such as the capacitic discharge, the power self, the toxicity, the safety, the thermal stability, the LCA, and etc. We have to compare each cathodes with each other, and then after the comparisons and the materials that we choose is lithium iron phosphate. But lithium iron phosphate is very low conductivity. So we want to add another transitional element in hope that it can boost its electrochemical performance. There are so many transitional elements that can be used as a boost to lithium iron phosphate. And then after we did material selection for the metal in lithium iron phosphate, which is manganese, the next step is in a laboratory scale, we have to choose the objective itself. So our objective is to synthesize and optimize lithium iron phosphate under various conditions, and then we want to characterize its alpha-chemical performance. This is our experimental methods first of all. After literature study, we have to synthesize the intermediate compound of the lithium manganese iron phosphates. After we successfully synthesize the precursor material, the next step is the synthesis of lithium manganese iron phosphates. And then we have to characterize its cathodes. After the characterization is complete and successfully conducted, and then the next step is the slurry preparation for coin cell batteries. After the assembly with lithium metal as anode and lithium hexachlorophosphate as the electrolytes, the next step is we have to characterize its electrochemical performance, and then the next And then the last one is to analyze our batteries. So first of all, this is the results of our battery. First of all, we have to ensure that the structural in our intermediate compound until the cathodes is matched with the database. And then after we successfully match the crystal structure and peak, and then the next step is we want to know the morphology of our batteries. And as you can see that the morphology is very vary from plate-like and flower-like. And then each conditions like acid, neutral, and alkaline condition will influence the morphology of the batteries, of the cathodes. And then the next step is we want to ensure that the elemental element, the transitional element in our cathodes is distributed fairly and homogeneously in the morphology. And then it can be characterized by ADS characterization. And as you can see in the show that the manganese element in D and the iron element in E is distributed fairly and in one side. This is important because we don't want to our transitional elements separate with each other. It is a very bad example of our sample. This is separate between iron and manganese, and it can be influence our electrochemical performance. And then after we successfully ensure that the elemental mapping and morphology is correct, the last one is the electrochemical performance by CV to know the working voltage of our batteries, and the last one is the capacity during charge and discharge during lithium intercalation and the intercalation. In figure A, this is the graph of cyclic voltammetry from one of the sample, and then we can see that there are two peaks in oxidized and one peak in reduction state, which means that there are electrons transfer between iron in lithium iron phosphate. And then these peaks consist of the change between manganese and irons. And then the B figure show the charge and discharge capacity of our battery. Unfortunately, our battery's capacity is lower than its theoretical capacity. The theoretical capacity is around 172, but our battery is just lower than 10 milliampere hour per gram. So it is very low in terms of charge and discharge capacity. But after we did reverse engineering about the charge and discharge capacity, we found that there are SEI or solid electrolyte interface that form during charge and discharge process. And this is the conclusions. First of all, the synthesized conditions of active test morphology, crystal structure of the cathodes, and then the optimum electrochemical performance include the working voltage and charge discharge capacity in a coin cell battery with a standard CR2032 with an arrangement lithium metal as anode, lithium hexylperoxide in ethylene carbonate and dimethyl carbonate as electrolytes, and lithium manganese iron phosphate as cathodes were 4.0 volt and 5.6 milliampere hour per gram. This is the reference, and thank you very much.
Okay, thank you, Ms. Anissa, for the complete data and the detailed explanation of the LMFP battery cathode, right? Same as before, maybe cathode is very important because it acts as a source of the electron And if we can maximize the electrochemical performance, it is a challenge to minimizing also the cost. Yeah, so the challenge is improving the battery capacity by optimizing the SEI formation or minimizing the formation to make the battery better. Okay, okay, for the next speakers, I would like to introduce Mr. Egi Aditama, the bachelor degree student from 11 Maret University, majoring physics education, and obtained his master degree from National Chiao Tung University, Taiwan, majoring in material science and engineering, and served as research assistant of National Chiao Tung University, Taiwan, a graduate student researcher National Chiao Tung University, Laboratory of Energy Storage and Electrochemistry, and an undergraduate researcher of 11 Maret University in Indonesia. To Mr. Egi Aditama, the floor is yours. Thank you.
Well, thank you, Mr. Chipta. Let me share my screen. Well, yeah, thank you for the nice introduction. It's been a pleasure for me to be here to give a short presentation about my research when I was in Taiwan. My name is Egi Aditama, and I am a former research assistant at the Laboratory of Energy Storage and Electrochemistry. I got my master's also from there, Material Science and Engineering, National Chiao Tung University. And I also would like to thanks to Professor FV, although we never meet in person, but I hope someday we can meet each other. And today's topic is about my research. It is about high voltage lithium metal battery with three-dimensional mesoporous carbon anode host and ether carbonate binary. Before I start, I want to put everyone on the same page with me. Maybe some of you don't know what lithium metal battery is, but we want to start from lithium ion battery. As previous speakers mentioned before, in lithium ion battery, typically we have three parts, which is cathode, anode, and electrolyte. And the lithium will move through the electrolyte from one side to another side. And today's technology of lithium-ion battery has already reached theoretical capacity. That's why researchers around the world start to work how to push the energy density of nowadays lithium-ion battery. So I divided into 4 generations, start from generation 0. This is even before lithium-ion battery has commercialized. And then generation 1, lithium-ion battery, but the energy density already reached the limitation. It is about 250 watt-hour per kilogram. And then the further is generation 2, which is we use silicon composite, and the energy density only up to 300 watt-hour per kilogram with the anode silicon. Okay, and still, if we are aiming for 500 watt-hour per kilogram, we're gonna move and change this silicon with ultra-thin lithium metal. And the cathode would be NMC or even sulfur. And with this kind of configuration, we can achieve up to 500 watt-hour per kilogram. And what is the difference between lithium metal battery and lithium-ion battery? Actually, in lithium-ion battery here, as you can see, we are using graphite as the anode material. But in lithium metal battery, we replace this graphite with thin lithium metal. It is about 50 micron for the thickness. But you may notice that if we change the graphite to the lithium metal during charge and discharge, yeah, the lithium metal will be exposed to the electrolyte directly. That's why it is thermodynamically unstable, because this instability to main challenge has arisen. First one is the dendrite formation, and the second one is low Coulombic efficiency. And one of the best solutions to overcome the problem is through electrolyte engineering. But here, no matter how good your electrolyte is, the dendrites will still be formed. Like in figure A, if we are using commercial electrolyte LiPF6 with ECMC, the dendrites still form like needle-like here. Although we add some trace amount of water, the dendrites still can be formed here. And also if we are using LiFSI with DME, still the dendrites will form. But strictly speaking, the electrolyte selection is still one of the best solutions to overcome this problem. And the second problem is low Coulombic efficiency. If you have a phone or laptop, your devices is closed system. And in closed system, if you want to have 3000 cycle with 80% capacity retention, the in Coulombic efficiency that can tolerate is very low. It is 0.01%. Here in figure B, you may notice if we have Coulombic efficiency loss, even only 2%, your battery cannot long last and it will fail even before 100 cycles. That's why in America, in figure C, a lot of academic institutions working closely together with national laboratory, with industry to know and to understand what's going on inside the battery when charging and discharging. Here in figure C, one phase of lithium become two and two become one. And this kind of research is pretty much important to really understand what happened inside the battery itself. So from those two problems, in my research, I know the novelty or the scientific gap is how to design the good electrolyte and how to build a host in order to advance the development of lithium ion battery. And if we are talking about the future, if we are talking about 500 watt-hour per kilogram for energy density, I think the research in cathode material has already, achieved this kind of challenge. But if we want to use 5-fold, for example, cathode material, the electrolyte is still the problem because, in research of lithium-ion battery, most of the researchers are using ether-based electrolyte. Though the lower reactivity with lithium metal, but this kind of electrolyte cannot compete if we want to talk about 500 watt-hour per kilogram. So in my research, I replaced this DOL with EC or ethylene carbonate because EC has a better oxidative stability than DOL. So we call our electrolyte LED and we call the most common electrolyte LED here. And then we test and in the anode part and cathode part. In anode part, our electrolyte in figure B here, even though we increase the current density up to 10 milliampere per centimeter square, the Coulombic efficiency is still pretty high compared to LDD electrolyte in figure A here. There is a voltage drop, and for the stability, it can work up to 150 cycles. Although we increase the current density up to 5 milliampere per centimeter square, still the battery can work, but LDD electrolyte even failed before 25 cycles. And in cathode part, we test the potential stability. After the replacement of DOL with the EC, the potential stability can shift it to right. And when we try with NMC 811 here in figure B and C, the LED electrolyte can work, although we increase the cutoff voltage up to 4.45 here. But the LDD electrolyte was failed in 4.24. That means the LED electrolyte is able to work NMC 811 if you want to talk about 500 watt-hour per kilogram. And that remarkable performance is due to SEA formation. And for SEA formation, we did XPS measurement, and figure A is correspond to LED, and figure B is correspond to LED. We know the very different peaks between those two. Here, very intense peak for LIF. On the other hand, LDD electrolyte, some incomplete reduction because we have SF peaks here. And in C spectra, we have a more intense, the peak for alkyl carbonate compared to LDD electrolyte. And this lithium carbonate also much more intense in LED electrolyte. And lithium carbonate, as we know, it has been regarded beneficial for the stability of the battery. And then after we finish with the electrolyte engineering, then we moved how to build a good host for lithium-ion battery. we compare with three materials. This is TM image. Figure A is one-dimensional CNT, and figure B is two-dimensional graphene. We have a very good image here, and figure C is three-dimensional mesopole carbon. And further, we want to call it CMK8. And in the left side, you may have a look here. Here is the morphology, SEN before and after cycling. Lithiated means the condition where the lithium is inside, and delithiated means the condition after the lithium is removed. For the plain copper, CNT, and graphene here, we have in lithiated condition, we have structural damage, and that lithium can be observed. On the other hand, for CMK, the morphology remains the same even before and after cycle. And for the stability, we got a pretty much better than literature because we can achieve up to 550 cycles compared to, compared to another material here. Graphene cannot work and fail even before 100 cycles, and CNT even before 200 cycles. And in figure here, we increase the current density. Still, the CMK8 has the best result compared to another materials. And here's the comparison with reported literature, and our study would be promising because we can achieve 550 compared to another material. This is all of this material is three-dimensional. So why CMK8 is the best compared to CNT and graphene here? This is Raman data. So figure A is for CNT, figure B is for graphene, and figure C is for CMK8 here. In figure E, in figure A, the B over D band before cycle is 0.95, but after cycles, the D over D band is changed. What does that mean? That means the structure of the CNT has changed, and there is shifted peaks toward lower and higher wave number. That means the chemical structure of CNT also changed, and that does happen also in graphene. We have a different D over G band and different D over G band after the cycles, and also shifted peaks. But in CMK8, there is no change, even D over G band or even shifted peaks. All of the things remain the same. And the shifted peaks attributed to the internal stress between the field within the carbon structure during carrying and stripping or during charge and discharge. So after those, all of the characterization, we try to do full cell configuration here. We coupled all the material with NMC 811 here, and CMK8 has the best capacity retention with 66%, and that followed by CND with 52, and graphene with 80% capacity retention. And what does that mean? That means the CMK act as the dimensional stabilizer, which minimize the lithium and dendrites, and the CMK8 has a meso-sized channel for lithium transport and also has three-dimensional continuous electron conduction. So I want to summary what I already talked before. The design electrolyte, LED electrolyte, was successfully developed and more preferable if you want to work with NMC 811. Maybe if you want to work with LFP, because the cutoff voltage only 3.6, LED electrolyte may be okay. But if you want to talk about the future, about high cutoff voltage material, I think the best solution is to have an electrolyte that can work up to 5 volts. And then the second one is the novel study of lithium metal battery by CMK is promising because it could extend the cycle life about 550 cycles with practical current density, 1 milliampere per centimeter square, with the ability to minimize the lithium and dendrites. And in this occasion, I also would like to thank my supervisor at NCTU there, Professor Chang and Professor Julie from MIT. Also, I want to say thank you for Dr. Ani for the collaboration and all the Indonesian colleagues here. I've been really happy to have you, Starsis, Daniel, Ozan Indita, Ahmad Prayogi, and Dia Ayu, and also my international colleagues. I think that's all from my presentation. I'd be happy to answer if you have any questions. Thank you.
Thank you, Mr. Egi, for the presentation on high voltage lithium metal battery. It is interesting that there is a new generation of the battery, which seems that the battery can be more compact since it uses the thinner lithium metal battery compared to the carbon. And for the next speakers, uh, I would like to introduce to you Mr. Muhammad Fahrudin ST. He is a researcher from Center for Science and Technology of Advanced Materials, National Nuclear Energy Agency, Batan. Graduated from the Bandung Institute of Technology, majoring in chemical engineering, expertise in lithium-ion batteries and X-ray diffractions, and served as research assistant Institute for Research and Community Service, Bandung Institute of Technology, or LPPM ITB, and currently serve as junior researcher Center for Science and Technology of Advanced Materials, PSTBM Batan. To Mr. Muhammad Fahrudin, the time is yours.
Okay. Can you hear me well? Okay. Thank you very much, Mr. Chipta. Thank you for the opportunities. Here I will discuss a bit about NCM cathode for lithium-ion batteries. Let me share screen first. Okay, my name is Muhammad Fahrudin. I'm a junior researcher from Center for Science and Technology of Advanced Material, National Nuclear Energy Agency. And I will discuss about NMC cathode for lithium-ion batteries. First of all, in 1980, LCO was first introduced by Good Enough. And then it was first commercialized by Sony in 1991 through their camcorder product. So this is the first portable electronics that use lithium-ion batteries as power source. And nowadays, lithium-ion batteries have been widely applied in many portable electronic devices and show great promise in large-scale applications such as electric vehicles. Among all the components of lithium-ion batteries, cathode materials are one of the most critical parts, which largely determine the whole energy density and cost of battery systems. The current commercial cathode materials can be categorized into three groups according to their structures, including lead oxide, for example, LCO, spinel such as lithium manganese oxide, and olivine such as lithium ferrous phosphate. And one of the most promising cathode structure is the lead oxide. And in this context, we mentioned that the 2019 Nobel Prize in Chemistry was awarded to Good Enough, Whittingham, and Yoshino for the development of lithium-ion batteries using lead LCO as cathode. LCO has a theoretical capacity of 274 milliampere-hour per gram, but the practical capacity is only 135 milliampere-hour per gram. The working voltage range is 3 to 4.2 volts. And the rapid capacity fading upon cycling and high cost are major disadvantages of this material. Okay, researchers thought that what if we replace the expensive cobalt to cheaper nickel? Unfortunately, synthesis of stoichiometric LNO is quite difficult due to the similar size of lithium ions and nickel ions. And nickel can migrate to lithium sites, creating disorder that hinders diffusion of lithium ions. Some research also try to replace transition metals to manganese, so-called LMO, but the performance is not good either. Mixing of the different transition metals has been proposed as a way to improve the performance of layered cathode. Reports on different binary layered oxide materials have shown that transition metal mixing is beneficial. The twin oxides combining nickel, cobalt, and manganese are usually referred to NCM or NMC, and NCM layered materials can provide capacities about 200 mAh per grams in the voltage range of 3 or 4 point in the voltage range of 4.3 volts. In this mixing phase diagrams, we can see that there are common NCM compositions such as NCM 333 with the same proportion of nickel, cobalt, and manganese in the center one. And also there are NCM 523, NCM 622, and NCM 811. Composition determination of nickel, cobalt, and manganese is based on physical features of each element. Nickel contributes to cathode capacity, and the effect of cobalt is electrical conductivity and reduce cation mixing. And manganese can improve structural stability on cycling. This is a typical charging curve of NMC. The oxidation or charging process starts with nickel 2 plus to nickel 3 plus, followed by nickel 3 plus to nickel 4 plus, and finally cobalt 3 plus to cobalt 4 plus. For manganese 4 plus, it remains electrochemically inactive. In general, the oxidation of nickel occurs under relatively low voltage, less than 4.3 volts, and the oxidation of cobalt only appears above 4.3 volt. Because the applied uppercut voltage, cutoff voltage is often below 4.3 volt, the capacity of NMC is mainly originates from the nickel redox couples. Layered NCMs crystallize in a hexagonal structure. Weak composition of 3A are occupied mainly by transition metal layers, while weak composition of 3B are occupied mainly by lithium. And this is a comparison of NMC cathode compositions and their capacities. This is only approximate value, and the exact values might naturally differ from other academic or commercial values. And as we know that nickel is the main capacity or the main capacity contributor, so the higher the nickel content, the higher the capacities. And for the cost, the simple talk that says that NMC 811 is the best NMC composition is that it needs less cobalt compared to NMC 622 or NMC 111, and that means it's a big savings because cobalt is very expensive and low abundance. As we know that cathode materials contribute about a quarter of the cell cost, while nickel and manganese prices are relatively low and steady because of cobalt is skyrocketed by more than 300% from 2016 to 2018. After full charging, we have nickel 4 plus, and it is reactive, and its excessive amount increases unwanted side reaction with the electrolyte, while manganese and cobalt do a good job in holding the NMC layer structure together. So expectedly, their content reduction leads to a decreased structural stability of the material. And as nickel content rise, NMC cathodes are more sensitive to elevated temperatures that affect the release of oxygen gas and also undergo more structural changes. We can see here the NMC 811 is easily to release oxygen gas from the temperature of about 100 compared to another composition. And to satisfy the continuously increasing demand for high energy density LIBs, researchers nowadays pay more attention to the nickel-rich NCM with the nickel content more than 60%. And the popularity of nickel-rich layered oxide originates from their high practical capacity, high working potential, and acceptable manufacture costs. Indonesia holds a big opportunity to develop its electric vehicles industry by having the largest global nickel reserves. NMC 811 is a potential cathode to develop in Indonesia due to the main composition of cathode is nickel. And we can see that LG Chem and SK Innovation claim that NMC 811 will be in mass production, and also BMW also expects to move to NMC 811 by 2025. Okay, the main problems and challenges of nickel-rich layered oxide can be summarized as follows. The first is the formation of residual lithium compounds, also gas evolution in high temperature, rock salt phase formation, microcrack of the particles, and also the dissolution of transition metals ions. Four main strategies have been reported to solve the problems of nickel-rich layered oxides and improve their electrochemical performance, including primary particle engineering, surface coating, doping, and also concentration gradient of transition metal in particle. So if we have a spherical particle, there's a difference in the concentration of the transition metal in the center of sphere and the outer layer of the particles. Okay, the summary of this presentation, NMC is one of the most promising battery cathode due to high energy density, high power density, and acceptable manufacture costs. And nickel-rich NMC, for example, NMC 811 as future lithium-ion battery materials. And the last is modification of nickel-rich NMC is needed before the utilization of the cathode in commercial application. Okay, that's all my presentation. Thank you.
Okay, thank you, Mr. Farudin, for such an outstanding presentation about the NMC battery. It is nice to be informed that NMC have different types of its cathodes, and the most recent technology is 811, which have less cobalt. That means more affordable battery for the future technologies. Okay, for the next session, we will have sharing sessions from Mr. Egi Aditama and Miss Lisda Ainia. For the first sharing session, I will let Mr. Egi Aditama. I will let Mr. Egi Aditama to share his experience and maybe share the opportunity to audience to study in Taiwan, right? Okay. For Mr. Agitama, the floor is yours.
Well, thank you. This is my second talk today. And I think you want to hear this presentation more compared to my previous talk. And in this occasion, I would like to share my experience in when I was studying in Taiwan. I think maybe I cannot cover all of my experience there, although I have lived there for 2.5 years. But first, why is it Taiwan? Why should be Taiwan? And there is some question for international student in from Ministry of Education why you should take the opportunity for grad school in Taiwan. The first reason is the scholarship availability. Actually, Taiwan right now under President Tsai Ing-wen, they have the policy. They call it New Southbound Policy. New Southbound Policy is the policy to encourage the student from Southeast Asia country to take grad school in Taiwan. So they provide some funding scheme from government, from Ministry of Education or Ministry of Foreign Affairs to study in Taiwan. And the second reason is academic resources and quality. I personally think that, studying in Taiwan a bit different with studying in Indonesia. I don't want to blabbering, but I think the most different part is the collaboration between industry and academic institution. Like, for example, in my experience, I also in charge of the industrial project. So every week I give the data to the industry, and industry will give funding to the laboratory. So it is like a mutualism symbiosis, right? And I think this is a quite bit different with Indonesia, where the industry is unlikely related with academic institution, although we start to move to those fields. And the third one is colorful culture. I think you may all know that Taiwan is Chinese-speaking country, so they have a very different background with us in Indonesia, from the language itself, and then from the behavior of the people, and also the society. I think this is worth if you want to learn more about Chinese, and even the alphabetical model is different with Indonesia. I think it's clearly different. So you want to, if you want to study there, I think it's worth to learn Chinese, although a little bit from Indonesia. And then better opportunity when you are seeking job back at home country, because in Taiwan, if you are majoring in science or engineering, you will have a very good, research ability. Because I think for the researchers, I think they will provide at all costs. And the location probably, and then high standard living quality. I think for the high standard living quality means in Taiwan, you are more preferred to use public transportation compared to use personal transportation, because there the public transportation is very convenient. You can go to everywhere using train, using MRT, or using bus. It's very convenient. I think it's quite different with Indonesia. And then better opportunity to further study in Taiwan or even outside Taiwan. Like in my case, I also will pursue my PhD in Germany after I graduated from Taiwan. And then reasonable and affordable tuition, which I will explain after this slide. And if you are majoring in electrical or in semiconductor or in mechanical or in material science, I think Taiwan is, it's not bad choice, because, Taiwan is, if you are aware with semiconductor world, iPhone, the IC is supplied from TSMC. TSMC is the industry, I think the best industry in Taiwan, which supply more than 50% of all over the world stuff in handphone. And I want to talk a bit about geography. So Taiwan actually is an island, but also they call themselves as a country. Uh, there's some long relationship with mainland China, and also if you want to see snow in Taiwan, I think you are unlikely to see there. Maybe you can, but you should go to mountain to see the snow. And for the food, if you are Muslim, I think a bit difficult to find a halal food, but there is halal food, but the price is a bit higher than normal food. But you can eat vegetables like you become a vegetarian in Taiwan. And now we move to study in Taiwan. So first of all, I want to say make sure you are eligible to apply as an international student because some of the department they only open for local students. And then make sure you've done research about program of your interest. For example, if you are physics student but your research is in material, I think you can also choose material science rather than physics. And also make sure that you are meet the requirements of the school and then fill the document correctly, and also make sure you send the application in time, and also uh, you have to think about tuition if you don't have any scholarship. But typically, if you want to go for master's or PhD, there are a lot of scholarship available for I want to explain after this one. But for master program, if you want to graduate, you typically you need to take 24 credits. But for PhD, maybe less than 24, maybe 18 or even less. That's depend on the department and also the university. But for PhD, you need to publish typically at least 2 papers in high impact factor. Okay. And the documents for submission, typically application forms and photocopies of original diploma. For example, if you don't have an English version of your graduation certificate, you need to translate it first to the Word translator, and then financial statement or scholarship, or and then statement of purpose and letters of recommendation, and some of the some of the university needs you to pay the application fee, and also you have to pay attention for other documents as they're required by university. Now this is for the best part. I think you need to hear this the scholarship that available for grad school in Taiwan. uh, First of all, I want to recommend you to take a scholarship from government. I mean Taiwan government, like MOE or MOFA. MOE stands for Ministry of Education, and MOFA stands for Ministry of Foreign Affairs. This is much more safe for you, and the stipends is a bit higher compared to others. And the requirement you can have a look on their uh, website. But in my case, my scholarship was come from university combined with funding from laboratory. So they combine and they give me like 10,000 NTD per month and tuition waiver. So I don't need to pay tuition. Like in Indonesia, we call it UKT. Okay, and this kind of scholarship actually I don't recommend it to you because this kind of scholarship is evaluated every 6 months in my case, and they will decide how much the amount of the scholarship you will get for the next semester based on your performance of the course and also the performance of your research. For example, if you get a score below 82, the scholarship, they will increase maybe slightly, maybe a lot. That's depend on the committee. So I think this kind of scholarship is not good for your mental health. So I, encourage you to take MOE or MOFA. And another scholarship is the IGP. And this is also, I recommend this kind of scholarship. And here is the website. You can find the further information about scholarship from NSC, MOEA, Ministry of Education. I think number 5, you need to have a look there. And personally, so this is my experience. Study in Taiwan is life-changing experience. It is worth it, but there's no such thing as freelance. So I think you need to have a resilience. If you are in science major and you are lucky to have ambitious supervisor, almost all of your life will be spent in laboratory. Like you come in the morning and then you go back in the middle of the night. I think that's a normal life for science major in Taiwan. Or I I can generally speaking for East Asia like Japan or South Korea. I think the same with Taiwan. And every week in the laboratory, we have personal meeting and group meeting. And this can push you, to give the data to your supervisor every week. And, this is maybe tiring, but life-changing experience. And because of that, the pressure, I think it is very high. So you need to maintain your mental health condition. And living in Taiwan, for example, I got one, like before I mentioned, $10,000 NTD, but my spending is about like 6,000 NTD every month. This is maximum. So in a month, you can spend about 4,000 NTD. And this is you can save much more than this if you cook by yourself and then your lifestyle is more lower than others. I think you can save much more money. So if you do have intention for grad school in Taiwan, I think you can go for it, but you need to consider about your your choices. And before that, I think my advice is for you is to continue your research first and then narrow down list of the schools you want to apply. There are a lot of good schools in Taiwan, and then you need to take English proficiency class. Most of them still accept TOEFL ITP, but I think much more safe if you do IELTS and then ask faculty members to write your letters of reference, can be your supervisor in your college or undergraduate studies or your boss if you already work, and then you need to have official transcript and your certificate of graduation in English actually, and then you start to write your personal statement and complete and submit your application. I think, and that's all from me. If you have any question, I would happy to answer that. Thank you.
Thank you, Mr. Agi, for your sharing session for the experience in Taiwan. And uh, it is happy to know that there are a lot of opportunity and there are a lot of scholarship from Taiwan. And there are two streams that I remember MOE and MOFA and a lot of scholarship beside that. So, and for the next sharing session, I will let Miss Lisda to share her experience and share the opportunity to study in Saudi Arabia, if I'm not mistaken.
Thank you so much.
Thank you.
Yes, thank you so much, Mr. Now back again with me is Daimia. For that, Assalamualaikum warahmatullahi wabarakatuh. I'm Lisa, and in this discussion, I'm going to share with you about study opportunities in Saudi Arabia. So before we're digging further into the study opportunities in Saudi Arabia, I would like to give you a disclaimer that I do not represent any universities and I do not speak on behalf of them. But as someone who was born and raised in Saudi Arabia and still residing in Saudi Arabia, I'm pretty much familiar with all the information and also with the admission process. With that in mind, so when I was an elementary schooler, I used to go to two different schools, or one elementary public school in Saudi Arabia, and also at the Indonesian School of Makkah. A brief information about Indonesian School of Makkah. There are actually 3 Indonesian schools within the kingdom. There is one in Makkah, one in Jeddah, and one in Riyadh. and all of them are adopting the Indonesian curriculum. For example, nowadays we're using the curriculum 2013, and then all of them, the three schools, are authorized by the Ministry of Education and also and Culture of Indonesia. So speaking about education, it's undeniable that education offers hope and dreams for a better future. That's actually one of eagers us the most, motivates us to continue to a higher degree of education for scholarship because we're seeking for a better life in the future. If you ask me about education in Saudi Arabia, how is the education in Saudi Arabia? The answer is they are free. For public schools, they are mostly free. They do not discriminate between a foreigner and a Saudi nationalist. As long as you're legal and documented, you are open to the access of education. So it's free from elementary until high school. But if you ask me another question, like, what about higher studies? So the higher studies are actually also free, but of course it differs from one institution to another institution. So make sure that you look that up yourself, making sure that the education is free. But there are some limitations, mostly when we're speaking about programs. So okay. Okay, thank you. I'm going to explain this again. So the higher studies in Saudi Arabia is actually free for higher studies, but it also it differs. It could be different from one institution to another institution. So make sure that you look that up yourself. And then, of course, there are some restrictions, especially when we're speaking about programs. Programs in Saudi Arabia, especially medical studies, are not allowed for foreigners. So if you are a medical student and looking for a scholarship to continue your medical studies, I'm sorry to say, but Saudi Arabia is not an option for you. And next, okay, so scholarship, or in Arabic it's minha. So scholarship, when we're speaking about the mutual and beneficial relationship between two countries, in this case specifically Indonesia and Saudi Arabia, there are so many ways to maintain that. And one of them is actually through scholarship. And in Saudi Arabia, there are two types of scholarship. There are inside, dakhiliya, and there's also outside or kharijiyya. So inside is actually for people who are inside of the kingdom, Saudi nationalists, residents, and also the people who are around the citizen around Saudi Arabia. From outside, actually for foreigners, and one of them is in Indonesia. So make sure that if you are from Indonesia and looking up for scholarship in Saudi Arabia, make sure that you are searching for the outside scholarship. And then, of course, scholarships come with terms and conditions. This is actually just a few of them. First of all, from age restrictions. So there is actually a wide range of scholarship in Saudi Arabia, from bachelor's to doctoral, but there is an age restriction. If you want to apply for a bachelor's degree, make sure that you are between 17 and 25. 25 is the maximum age. And then for master's, it's before 30, and doctor is before 35. And then one scholarship, and then the second thing is that one scholarship only, meaning that if you have received a scholarship, you are not allowed to looking out for another scholarship. The third one is actually about legalization. This is actually the same requirements with another scholarships. It's just basically the same. So make sure that your documents all of them are legalized. And then the next thing is that for female, this is actually the what makes Saudi Arabia different with other countries. For female student, is a little bit, there is some blocks along the way. So for female, you must have a mahram. Mahram, it means that you're related. For example, your father, your brother, or your uncle. The list goes on. Make sure that you have someone to bring to Saudi Arabia, just not yourself. For females, and then Just early this year, the government of Saudi Arabia announced through the Ministry of Foreign Ministry of Indonesia that the gate of admission for scholarships for 20 universities. Here are the list of universities. You might, if you are interested, you might take snapshot of it. This is 12 universities, and then this is the rest of it. So if you're interested, please look that up, search for the website, and then read the requirements and everything, and make sure that you apply on time. Basically, the admission for foreigners is actually open through the year. Whole year is actually through the whole year is actually open, but for study scholarships, it's actually kind of slow to process that. You must wait minimum 1 year. Actually, that's it. So you must be really patient if you're really eager to continue your degree and so. And then after this, I'm going to present you with the top universities in Saudi Arabia. First of all is King Abdulaziz University of Jamiat Malik Abdulaziz. King Abdulaziz University is located in Jeddah, and currently, according to the QS World Ranking, they rank 143rd globally. And in the region of Middle East, they are the first university, of course, and within the Saudi Arabia region, they are the first university. This is actually the video of the university itself. And then second one is Jamiat al-Malik Saud or King Saud University. So King Saud University is located in Riyadh. Riyadh is the capital city of Saudi Arabia, and King Saud University, if I'm not mistaken, historically is the first university in their history. So this is their first. And then the third one is the first one is King Fahad for Petroleum and Minerals. This university is located in Bahrain, Saudi Arabia, and there are famous for the excellent programs in science, engineering, and business management. So if you're looking for a program with specified and focused programs in those programs, for example, science, engineering, and business management, might as well apply for King Fahad for Petroleum and Minerals. And first one is the Jami'ah Qura or Qura University. So Jami'ah Qura is located in Makkah, the holy city for Muslims in Saudi Arabia. And historically, Qura University is actually just historically they just focus on Islamic studies. But nowadays there are more diverse. The programs are more diverse from science to business management. So the last one, I'm going to show you the Princess Noura bin Abdul Rahman University or Jamia Amira Noura. Jamia Amira Noura bin Abdul Rahman. This is actually a female university. So male, you're not allowed to apply to this university. You're going to be rejected right away because you're not a female. So this university is actually a female university and the biggest female university in the world. The fact that the university is so big that the university decided to provide with a modern automated train to ease the students to migrate to move from one building to building, just to make sure that they are on time because the university is so big. And for currently, they're focusing with bachelor's program. With masters, they're still focusing. Okay, that's it from me. If you're interested to apply to Saudi Arabia, my advice is apply as soon as possible. Thank you, and wabillahi taufiq wal hidayah. Assalamualaikum
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the interesting experience about the Saudi Arabia. There are the educational maybe mostly free, but unfortunately the medical school is not for the foreigners, right? But there are some great university, and what is interesting is that there is a female university in the Saudi Arabia also. Okay, for the next session, before we advance to the Q&A session, I would like to introduce our panelists. Prof. Alan Drew, BSc MPhil PhD, Professor of Experimental Physics, Queen Mary University of London, Distinguished International Professor, Sichuan University, China, Reader in Physics, Queen Mary University of London, and Senior Lecturers in Physics, Queen Mary University of London, and Lecturers in Physics, Queen Mary University of London, Leverhulme Fellow, Queen Mary University of London, Ober Assistant, University of Fribourg, Switzerland, and 1851 Research Fellow, University of St. Andrews, PhD Physics from University of St. Andrews, and MPhils from Materials Engineering, University of Birmingham, and BSc with Honorable Physics from University of Birmingham. So for this session, I'm pleased to let Prof. Alan to give comments and to give a question to the speakers. Prof. Alan, the floor is yours. Thank you.
Thank you very much, everyone, for some amazing talks. I'm afraid I don't know which speaker spoke about what, but I did listen to what speaker, if you understand. I just don't remember the names of the people that spoke. So one of the talks somewhere in the middle, they gave a fabulous history of lithium-ion batteries, where they were showing initially the unsafe batteries where you had a large amount of lithium metal, all the way through to the next generation of batteries. And in that list, there were some lithium-ion batteries where you had some silicon included in the anode. And I was wondering whether you could comment on that, because that's certainly something that I've been thinking about including having silicon nanoparticles coated with carbon to improve the capacity of anodes in sodium-ion batteries. And I was wondering what parallels there are between lithium and sodium-ion batteries, and what the role of silicon is in lithium-ion batteries.
So, who answered?
And I'm sorry, like I say, I wasn't aware of that. I was going to be asking questions, but I did have some questions. I did think I really should think about that.
Someone can answer the question about the safety, probably from Mr. Egi. Mr. Egi?
So Mr. Egi cannot unmute. Yes? It seems that the speakers can't unmute until we're allowed to.
Tolong di unmute.
The question is about silicon and sodium. Do I have a comment on that? I think the problem about silicon, although it has a better capacity, but the volume expansion is a problem. As we know that if you have silicon during the process, the volume expansion would be 4 times larger, expand and then shrink. I think for the results of the silicon, the first is we need to have, with composite to be able to couple with silicon. So that's why during charge and discharge, the volume expansion can be minimized. I think if we have 500 cycles with 80% capacity retention for silicon, I think that would be enough for preliminary study. Speaking about sodium battery, I think although it's more abundant compared to the lithium, sodium-ion battery is still difficult because the size of sodium is much more larger compared to the lithium. And either aluminum or sodium. I think that's my comment. Thank you.
Okay, so do you have any thoughts about the nanoparticles contributing to increased capacity without and longevity of the cells?
Yeah, I think for nanoparticle, the most important thing, because it has a higher surface area, and when you have a high surface area, the electrolyte composition will be much more harsh. I think we need to consider that. And apart from that, we also need to consider the conductivity. I think that's also important. And the ability to store the lithium itself. I think for the nanoparticle, that's important. And some people, I think, already published about for the silicon, like from E3 group from Stanford University. They also work with nanoparticle for the silicon. I think the result also remarkable. And maybe if we want to start working on that, we need to fix our electrolyte first, in my opinion. I think maybe a different person would have different opinion. I think with silicon, we need to fix the electrolyte first. And nowadays, maybe FEC is a good solvent for the silicon. And then after we fix the electrolyte, then we work how to engineer the silicon part, composite with nanoparticle or something else. I think that's my opinion.
Okay. I guess my last question is to the first speaker, who spoke about life cycle analysis, and I was just wondering how accurate is life cycle analysis with the current tools, because I've never been fully convinced that we're able to do life cycle analysis properly. Just I look at what government policies on for energy, and I see stupid decisions being made across every government, my government, every government. There's no, they are, you know, they're promoting certain technologies that probably have a life cycle energy cost which is far greater than current technologies, except that that energy is used in another country. So it's like they're prioritizing their own carbon dioxide emissions in their own country ahead of those in the world, without realizing that the world is what's important, not a particular country. So there's no point having a product that creates more carbon dioxide overall, even though it doesn't create as much in your own country. That doesn't make any sense. So I was just wondering, are the geopolitical aspects put into life cycle analysis? Is life cycle analysis fully accurate? So I think that was the first speaker.
Yes.
Okay, I will give my opinions how life cycle is accurate or not. It is actually depend on the data and the assumption that is used when we analyze life cycle process using a life cycle assessment. Actually, we need to compare it with standard, and the standard is maybe different for each country due to the differences of no, I mean geography, the geography, because and the geographic is affects to the result of the LCA, sir. And actually, we need to normalizing it and we need to deal with the right baseline and also the databases. The databases development is very important. Yeah, I think that's all my answer.
And how might one improve the database?
To improve the database, we need to do our research in the laboratory. So we need to record all of the data that comes from the process, and then after that we insert all of the data to the database software. Yeah.
Okay, so it's just a data collection issue. That's the main problem with life cycle analysis. All right, thank you. So I've been asked to ask 3 more questions. This is to Bakuni, I'm afraid, Rizka Bakuni, I think. Can you explain? I know this is from Rizka. Can you explain how to prepare the graphene? Was there any reduction process?
Okay, sir. May I share screen?
Yeah, of course.
Okay. Okay. Actually, my previous research is sorry. Wait. Okay. I want to make a disclaimer that I didn't do graphene synthesis in the laboratory, but I make a review process of graphene synthesis that conducted by Muramatsu et al. And this is for the graphene production that use a rice husk. So at first, the rice husk is carbonized to become the rice husk S at temperature 400 degree. After that, it is activated using potassium hydroxide, and then doing a filtration using the mineral water. After that, the drying process using vacuum drying, and to the result graphene. For the graphene synthesis that using electrochemical exfoliation, we need a flat graphite as the raw material. At first, we need to make the graphite that is hydrophobic to become hydrophilic by rinse it in a nitric acid. And after that, we need to neutralize the flat graphite using water. And after we got the dried flat graphite, we dried it, and after that, this is the main process, the electrolysis process in ammonium sulfate solution. After that, we need to centrifuge the result to become a graphene solution, and then we need resuspension, and after that we freeze drying to get a graphene powder. And this study was conducted by Che et al. In 2018. Okay. Was it clear enough?
Thank you.
Yeah, I think so.
Yeah. Okay, thank you.
Okay, so I have another question that's been sent to me. This is to Lizdia. Why the trend in decreasing LFP is something that cannot be avoided, by the addition of solid electrolyte in the electrode, how can you produce an all-solid battery, so a solid-state battery?
I'm sorry, sir, but the connection was kind of low. Can you please repeat the question again?
Yes, of course. So why the trend of decreasing LFP is something that cannot be avoided by the addition of solid electrolyte in the electrode, and how can we produce an all-solid-state battery?
First of all,
there are three questions, actually, yeah.
Okay.
At least there are three questions.
Thank you so much, Professor Ellen, for the question. I'm going to answer it first. From the last question, how we do produce an all-solid-state lithium-ion battery. It depends on the name. So an all-solid-state lithium-ion battery, every component within the battery has to be a solid form. So from the cathode, anode, electrolyte, and also the separator. The batteries in the market is usually using liquid electrolyte. So now in our project, we're trying to convert it into liquid electrolyte first. And then the second one, how is the addition of a solid electrolyte increase the conductivity? Is that your question?
So why is the trend in decreasing LFP is something that cannot be avoided by the addition of solid-state electrolyte in the electrode? That's the question I've been sent.
Okay. Right. After we added the acetylene black, the conductivity did increase from the order of minus 9 until -4. After the acetylene black, it did increase until 10 to the power -4. It means that the addition of acetylene black did increase the conductivity, which means that it kind of changed a little bit of the structural properties of the material. However, not until the nanostructural. That is why it did increase the conductivity, but it did not change the structural properties of that material of the LFP. However, with the addition of electrolyte, I showed you the 5%. We also have actually the addition of 10% and 15%. After the addition of 10% and 15%, there is actually an increment of conductivity.
Okay, thank you.
Okay, thank you so much.
So I have a question now for Anissa, and please forgive me if I'm not pronouncing names properly. So what kind of information do you get from the morphology of synthesized electrodes? Sorry, I'm reading this and this. I've tried to interpret. And what influence and how does that influence the battery performance? So this is to Anissa. There we go.
Yeah, thank you, Prof. Alan, for the questions. And for the morphology, actually, it is related to the crystalline size in the morphological side. And also, at the beginning, we want to know if the material itself can be formed into a nanosheet as example, nanosheet or nanoplate or flower-like. So we want to know what contributes to form the morphology. And then for the influence of the morphology to the electrochemical performance, maybe it's not related directly, but in my opinion, the size of morphology will affect the electronic conductivity in cathodes, in lithium intercalation and the intercalation process.
Okay, thank you. And then I think this is my last question that I've been sent, and this is to Fakhrudin. And again, please forgive me if I'm not pronouncing that properly. So the question is, what is the next generation battery that's based on nickel-rich materials? How could we produce it? And is Indonesia capable of being the player in the manufacture of this battery?
Mr. Fakhrudin. Mr. Fakhrudin, is he there? Can you find Mr. Fahrudin, speaker? Muhammad Fahrudin, still there? Can you answer the question? Can you unmute?
Okay, I've just got a message saying that his connection is not good. So it might be that he cannot connect.
Okay, yeah, maybe yeah, someone can help to answer the question about the nickel. Maybe I should help. So
yeah, you want to answer it, Eddie?
That's my question. Okay,
it's your question.
Well, I should not answer. Yeah, Alan, you should answer that question.
I have no idea. I don't know anything about cathodes. I work on anodes. You don't put nickel in anodes.
Okay. Okay. Well, this is good. Good. It's good for laughing. Okay. Okay. So Indonesia currently is the largest production of the nickel source in the world. So I think because as explained by Mr. Fahrudin, that the nickel rich containing 80% of nickel. So it means that the future of the battery electric vehicle will be based on nickel. So therefore, the answer is Indonesia has to play the role of producing the battery material, yeah, and also can produce the battery cell, yeah. The manufacturer has to be built in Indonesia. So this is one of the NBRI vision. So to enter. Okay, that's probably the question, Alan. Well,
all right,
Alan,
perfect. Thank you very much.
Alan, maybe we should give the appreciation to all the speakers. Very good speakers. Today we have the millennial. Yes, we should give the token appreciation. Okay, Sinta, can you share?
Yes, please wait a minute.
Yeah, Alan, please, please mention it.
Okay, when the screen comes, at the moment, here we go. So this is a certificate of appreciation for all of the speakers that I gave a talk today. So the first one is Adit Triuguno. I think maybe I'm the wrong person for this because I cannot pronounce the names, who spoke on the current state of battery research and experience study in Taiwan and Saudi Arabia. Okay, so the next appreciation goes to Rizka Ayu Puspita. So thank you very much for your excellent talk. I really enjoyed it. I mean, I enjoyed all the talks this morning. The next one is a great thank you to Lista Ania for the talk they gave this morning at today's workshop. And then I'd like to thank Anissa Wijayanti for another great talk. All of them were great this morning, or this afternoon for you. And a great thank you for Egi Aditama. And then Mohammed Fakhruddin, thank you very much. And I'm very sorry that your question was not able to be answered by you because of your poor connection, but that's the life in which we live at the moment. And myself, I'd like to thank myself, of course. I don't think I need one of those.
From me. Thank you, Alan.
Oh, Professor Evie doesn't get a thank you.
Oh, wait, there's another one, please.
Oh, there's another one. Fabulous.
So, from Alan, thank you.
Yeah. Thank you to Kipta Panghagar Supriyadi. Again, forgive the pronunciation there. This is a very different construction of language to my own one. Maybe I should learn some Indonesian at some point.
Yeah.
And thank you to Professor Evie for organising
Yeah.
the event and the team at the NBRI. Mustn't forget the team at the NBRI who have done a fabulous job behind the background organising this.
Thank you, Alan. Thank you for all. Thank you all the team, the member, all the speakers, and also the committee, the organizer, the moderator for this. I think it's great event. Yeah, I enjoy the talk really. Yeah, even from the young researcher, they are the future. Of the battery all over the world. Okay, so what is the rest is we have to take a picture or some information. We want to give the information, Cipta? Take picture first, summarize. Okay, okay. So, well, I asked you to summarize, not me, Alan. Yeah, maybe can you summarize the before closing?
I think maybe you're best placed for this, Evie, but I mean, my summary is that I enjoyed all the talks today. I learned a few things. I'm certainly going to send a couple of emails afterwards to contact a couple of the speakers about some ideas that I had. So I'm certainly interested in a couple of the, in particular the life cycle analysis, because I'm going to be working a little bit in policy work in the future, and I think this will come into it, and also the silicon inclusion, because I haven't done any silicon inclusion yet, and I know I've got some ideas about how we might want to proceed, and it'd be great to have a collaborator on that. So, yeah.
Okay. Yeah. So I summarize also that all the great speakers, great talk. Yeah, they give another insight of the future generation battery about graphene. Yes, that will be the future. Yes, and also the solid state battery, also the future generation of the battery. Yeah. And also the one that the new Electrolyte, found by the group from Taiwan, Mr. Egi, and also the other the mix of the lithium iron phosphate and mangan phosphate that is from University of Indonesia. This is also new interesting cathode material, and then also what is the current issue of the nickel mangan cobalt that nowadays really in discussion not only in Indonesia, I think all over the world. So that is my summarize that I enjoy all the talk. Then we some of you have been the member of NBRI, but I think that now it's open for all of us to work together. Yeah, as Prof. Alan said, we open the opportunity. Yeah, either internship, either collaboration, either whatever we can do together to bring not only our nation. This is for the world. So that is my comment. Yeah, and where I will give you a platform to gather all the stakeholder. Yeah. Okay. Thank you. Thank you again. Yes, that's my conclusion. Thank you.
Thank you. Bye bye, everybody.
Yeah, not yet. So we give to the to take a picture. I think we give
I'm
to
sorry.
the moderator. Okay. Yeah.
Yeah.
Thank you for all participants. Could you please turn on the camera so we can take pictures together? Thank you. Okay, to all participants, could you please turn on the camera? Wait, we will wait in a moment. Okay, so let's take a picture in 3, 2, 1. One more. In 3, 2, 1. Okay, the picture is done. Go back to you, Mr. Moderator.
Okay, thank you.
Thank you,
Thank you, Ms. Sinta, and thank you, Prof. Alan, for the summary, and Prof. Evi also for the summary, and for leading the Q&A session. Thank you. And for all of the speakers, it is nice to hear the outstanding talks and very personal knowledge I get from the all of you, especially for the battery and the next level battery like the thin lithium metal batteries. And thank you everyone for joining this session. I will give it back to Sinta as the MC for the further announcement. Thank you.
Okay, thank you so much, Mr. Chipta. Thank you to Prof. Alan Drew and also Prof. Evi, and also all the speakers. But before we end this event, I would like to let you know, as the Prof. Evi mentions, we on the NBRI have lots of opportunities for all of you who wants to join with us as our member. But before that, I would like to show you how to be a member of the NBRI. Okay, first of all, you can see my screen. Go to the n-nbri.org, and then you're going to log in or register. So here, if you are already a member, you can fill out all the profile informations, or if not, you can click I'm not a member, register now. How to fill this? First of all, you can choose individual if you are a researcher, research institute if you as a research institute, and also corporate if you're coming from the industry. And the second, you can choose either you are Indonesian or international citizens. Then you can click here, either you're a student, researcher, or also coming from the private company. For the membership plan, you can pay membership. And then all you can do is just fill out all of the information from email, password, first name, username, and so on, and then just click register. It just takes one click away to be our member. So don't forget to be our member and get lots of opportunities and also lots of information from the NBRI. And also on our website, you can see, as Mr. Adit mentioned before, there is lots of researcher, publications, opportunities, education and skill, news and event, and we always updating the news and event. But before that, last announcement is next Friday, we're gonna have next lecture, which is from Sarah Zab, from PhD from Howard University, and also Dr. Quinton L. Williams, professor and a chair of the Department of Physics and Astronomy, also from Howard University. So pick the date on 19, on Friday, at 9 a.m. GMT +7, it means Jakarta time. And here is the link. So you can just click the link and then register yourself before the seat is full. So that's all the announcement from me. Thank you very much for all the participants. So the meeting is done. Thank you so much, everyone, and see you at another event. Yep.
Yeah, maybe they want to learn also. That is the coming event is that the lecture from United States, yes, Howard University from state, yeah. So besides Sarah, Dr. Quentin will explain also how to study in USA. Okay, so welcome, join to the next event. Thank you again.
Thank you, everyone.
Yeah. Thank you, everyone. You may leave the room soon. Thank you, and see you at another event. Have a nice day and stay safe.